Hey guys, it is Obi here. We are going to start talking about gears today. I don't know if you guys remember, but when we were last in class, we were actually getting ready to move on to camshafts. I decided we probably ought to skip that for now because it's a little bit hard to completely wrap your head around, and you guys are going to be so busy trying to make sure you figuring out how to do the online learning that I think gears is going to kind of get you into it a little bit better. So we're going to just jump around a little bit. So we'll start out, we're going to talk about gears, and we're going to ask, what is a gear? So a gear is a wheel with teeth, and we use it to transmit torque or change speed. Gears are used pretty much everywhere in the automotive industry. We definitely see them in transmissions, on the engines, even in the actuators that control your HVAC controls. Literally, they are everywhere. And it's not just in our industry. We use them on machining components and probably just about anything you can name. So when we talk about gears, we need to understand that they are directly connected, and the output rotation is always opposite of the input gear with two gears. So what I mean by that is that the driver gear is going to be causing the rotation. So if it is spinning counterclockwise, our driven gear has to spin clockwise. There's no other way to do it. If it changes, that means you've probably stripped these teeth out, and that's bad. That means we have another problem. Now, another example of a gear is going to be a pulley. So when we look at this, we notice that on a pulley, we are actually, our driver is actually spinning clockwise, and our driven is also going to be spinning clockwise here in just a second. There we go. So we see our driven also spinning clockwise. When we do not have the physical connection from gears to gears, we have this belt that's transmitting the torque or the power. In that situation, they're both going to rotate these same directions. We have to make that distinction and make sure we understand it. So one other version of this that we could get would be a chain, like what you would have on a bicycle. And that's kind of a combination of the two. It has the sprockets or the teeth, but instead of a belt, it's actually got a chain that bites onto that. It operates similar to a pulley. So when we calculate gear ratios, which is what we're getting ready to do, it's really the same for both. Okay, so a gear ratio, we need to make sure we understand, is a comparison of the size, RPM, and torque between the two gears or pulleys. We have to remember it is always comparing the number of turns of the drive gear to one turn of the driven. So we are always going to express it as a number to 1. So on this example, the drive gear is going to rotate 2.4 times for every revolution of the driven. Okay? So we have to figure out how to do that calculation today, and that's going to be your guys' assignment. So when we calculate this, it's not really too terribly hard. Oh, let's go back. It's not too terribly hard. So the way we set our formula up is it's going to be gear ratio equals the diameter of the driven pulley or gear. So if we're talking about a gear, we would be considering the number of teeth the driven, okay? Just to make sure everybody understands that. And then the diameter of over the diameter of the drive pulley or gear. So the important thing is, whether you're dealing with a pulley or a gear, it is driven over drive. Driven over drive. Don't forget that. So let's do an example. We're going to look at our gear set here. You can see that we have a drive gear and a driven. The driven is definitely bigger than the drive. And we see our number here. So we have 20 teeth on the driven, or on the drive, I'm sorry, and then 30 teeth on the driven. So let's set this formula up. So we know it is driven over drive, and we are going to cross multiply, okay, when we do this. Now, just so you guys know, this is a pretty easy problem to figure out. You probably don't even have, you really don't have to cross multiply this. However, we want to get in the habit of doing this because some of the steps we're going to take later when this gets a little more complicated, cross multiplying is going to help us a lot. So let's get in the habit of understanding how to do it now, okay? So we know our drive pulley is 20 teeth, and then drive is the lower number on the formula. So we are going to put 20 on that bottom and then 30 up at the top. Now anytime we are doing this cross multiplication, you guys might have already done it, we are going to cross multiply those two numbers. So what we are going to do is multiply 1 times 30. We're going to put that over here. And then x times 20, which is going to give us 20x. Okay? So when we do that, those numbers go straight across. So now we have a new fraction that is 30 over 20x. So we have to do the math to figure out what that is. And if we do that, 30 divided by 20 to get x to 1x equals 1.5. So x would equal, so x would equal 1.5, which would give us a gear ratio of 1.5 to 1, because you remember we are always comparing the number of turns of the driver to one turn of the driven. So with 20 teeth on the driver and 30 teeth on the driven, this gear has to spin 1.5 revolutions until this gear makes 1 revolution. I hope that makes sense to everybody. It shouldn't be too bad, but if you're confused, you need to make sure you get a hold of me or Mrs. King or Mrs. Randolph, and we will be glad to help you. Now, I need you guys to understand that this is what is called an underdrive ratio. An underdrive ratio means the speed is greater than 1 to 1. So it will increase torque when we do this, but we are going to lose top speed, and that's kind of the trade-off that we're going to get. There's no free lunch, right? So we are trying to get the more torque out of this situation. So this would be a lower gear, like let's say a first gear, to get that car to take off. So let's do another example so we can try to make sure we've got our heads wrapped around this a little bit. So this is another example. We have a drive gear teeth of 27. So our drive gear is going to be 27 right here, and then our driven is 20. Okay, we're going to do that same setup. We're going to cross multiply. So we are going to do x times 27 and 1 times 20. Just so you know, remember, we are always making it over 1. So that 1 right there is always going to stay the same. It's never going to change when we're talking about gear ratios. That might change in other math that you do, but not when we're talking about gear ratios. So after we do that math, we're going to get 27x over 20. Now when we do that math, it's going to be a little different this time. So we're going to see that our gear ratio is 0.7407, which we would reduce to 0.74 to 1, okay? So that means that this big drive gear has to spin basically 3/4 of a revolution before the driven gear will make 1 full revolution. So this one is actually rotating slower than the output, which means that in this situation, we are going to have an overdrive. It will increase the top speed, but it's going to decrease the torque. That's a trade-off. So now, let's figure this is like 5th gear in the transmission, and now we're cruising down the road. We want to get the engine RPMs low so we're nice and efficient. That's kind of the whole entire goal with gears and ratios. So let's go ahead and review on this really quick. On an underdrive ratio, example, a 4 to 1, the drive gear is spinning faster than the driven. This is going to increase torque but reduce top speed. Now here's one we didn't talk about, but this is a very important gear, which is direct drive. It means it's exactly 1 to 1. There's only one time that we get a direct drive. It can't be 1.01 to 1. It can't be 0.99 to 1. It has to be 1 to 1. The drive has to be spinning the exact same speed as the driven. If it doesn't do that, we are going to be either an underdrive or an overdrive. But in this situation, torque and top speed will remain unchanged. We use this, typically it's 4th gear in an engine, or on a transmission, just so you know. Okay, and then finally, we have our overdrive ratio. So overdrive is going to be lower than or below 1 to 1. So an example, should be a decimal place there, but 0.87 to 1. The drive gear is going to be spinning slower than the driven. Okay, so we are going to get an increase in speed on the driven gear, but we aren't going to have as much torque available. Remember, this is like a 5th gear. Okay, so I hope this helps you guys. You are going to need to work on that assignment, and you can either edit it and then just turn it in on Microsoft Teams, or you can print it off if you have access to a printer, fill it out, take a picture, and send it back on Microsoft Teams. That's perfectly fine too. The only thing you can't do is text it to us because it's not a high enough resolution for us to get it. Okay, if you guys have a problem and you're unsure how to submit the assignment, please give me a call. My number is 937-423-7118. And just so you know, gotcha. All right. Have a good day, guys.